Okay. Review for the test. Now, first off, this problem won't work because there are two numbers that multiply to give you 45 that add up to 14. Oh, sorry, it was 15. It's been corrected. So, x squared plus 14x plus 45. Two numbers that multiply to give me 45. 9 times 5, and 9 plus 5 is 14. Okay. Now, another way you can use the calculator to help you to verify this is if you put this in the graphing calculator, okay, x squared plus 14x plus 45, and you graph it, you can see the x-intercept is going to be negative. And then you come here and you go to the negative side and look for some zeros, and there they are at -9 and -5. Now, the calculator kind of gives you that answer of the intercepts, but you still need to go back into this form and be able to realize that -5 and -9 would give me x plus 9, x plus 5. The calculator can help you verify that you factored correctly if you're struggling with factoring. All right? Number two, the only thing we can do here is GCF and take out a -3. But that gives me x squared minus 4. And then this factors further because the difference of two squares into x plus 2, x minus 2. But again, look what happens. If I put this in my graphing calculator, clear it out, whoops, and do -3x squared minus, oh no, it's plus 12, isn't it? Plus 12. And graph it, there's my 2 and -2 that I can find from the table. So the calculator is your friend, and it will help you if you utilize it properly. Now, there's going to be a little bit longer video just because of all the calculator work, but it will make it easier for you. And if you need to fast forward just the ones you need to, go ahead. All right, right off the bat, number 3, this is intercept form. So right off the bat, we know that we're going to have a dot here at -2 and -4. All right. We know since it's positive, it is going to open up and therefore have a minimum because it's a smile. All right. And I know my vertex is going to be right in the middle of those two. So one way to do it is add -4 plus -2 and divide by 2, and you're going to get -3. So you know it's going to be -3 comma something, and that axis of symmetry is right off of that x right there. We also know the vertices are going to be the intercepts are going to be -2 and -4. All right. You can also write -2, 0, -4, 0. But otherwise, and we know this all the time, all these parabolas are going to have a domain of negative to positive infinity because they're going to keep going left and right. Now, let's use a calculator. Right? So we're going to go to the calculator, go to y equals, clear out what we have, and put in 2 parentheses x plus 2 parentheses x plus 4 parentheses graph. There's my little happy parabola. And I go to the table and I find some points. Now, obviously, I won't be using 16, but otherwise, I have -3, -2. That's my vertex. And then I have -5, positive 6. And -1, positive 6. And that is enough to give me my general shape of the parabola. Now, what is the range? We get the range from right here. Remember this -2, because it is bottoming out at -2. So therefore, where's it going? It's going up towards positive infinity, which is always on the right, and it drops down and hits -2, so we use a bracket. And that's it. Number 4. Notice it says convert to intercept form, which means factor it. All right. But let's go ahead and get this in the calculator right now. Clear out what we got. So x squared minus 16x plus 63. Now, hopefully you can factor that and say what you know is multiply to give me 63 that add up, because of this, add up to 16, 9 and 7. And they're both going to be negative because of the negative 16. But if you had trouble with that, first you hit graph, and you can see they're going to be on the positive side. And there we have it at 7 and 9. Because when we factor this, it's going to factor to x minus 7, x minus 9, which gives us 7 and 9 as our intercepts. Okay, where's the vertex going to be? It's going to be right in between those. Okay, 7 plus 9 is 18. Sorry, 16 divided by 2 is 8. So we have intercepts there at 7 and 9. Another way, which we learned later, is we can take the opposite of b over 2a, and that would have given us 7. All right. But either way, I'm going to go to my calculator now and see what negative or 8 does. It gives us negative 1. So that's right there. And then a couple other points, 6, 3, and 10, 3. And that gives us a general idea of the shape of this graph right there. So it obviously is opening up, which means it has a minimum. It has a minimum here at negative 1. Right? My vertex, we said, was at negative 8, I'm sorry, positive 8, negative 1. And therefore, the axis of symmetry is at x equals 8. The domain is not changing. My range comes from my y. It's going up to the sky. So positive infinity on the right side and negative 1 right there. All right, convert into standard form. That just means multiply and then distribute. So I'm going to leave the negative 4 and just multiply. So x times x is x squared. Then I'm going to have negative 3x plus 1x on the inside, and then negative 3 here. I'm going to combine like terms before I distribute. So I'm going to get x squared minus 2x minus 3. And then remember, send this negative 4 here, here, and here. Which is going to give me negative 4x squared, positive 2 times 4 is 8, x, and positive 12. Gives you the negative times the negative. All right, graphing quadratics in vertex form. So to put them in vertex form, this is that completing the square. If you're struggling with that, go back and look at your notes from the previous section before the last quiz or the last review, and you need to practice this because it's going to be on the test. So remember, first step is leave a space and move that 5 over. And when we do that, some of you are doing this mentally and you're just writing 5 on the other side. If you're doing that, making that mistake, show your work and realize it's negative 5 on the other side. Now you simply just take this number here and take half of it, x minus 4. We're going to square that and write that up here. This is always going to be a positive number because squaring a number always is positive. What we do to one side, we must do to the other. And that gives me 11. Now, in the previous part of the unit, when we were solving, we would square root both sides, okay, and we would get the solutions. We're not looking for the intercepts. We're looking for the vertex. So we're not going to square root both sides. We're just going to move this back over by subtraction, which gives me x minus 4 squared minus 11 equals y. Okay? Now, we're not writing it, but I'm going to anyway. So the vertex is going to be at negative 4. I'm sorry, my bad, 4, positive 4, because it follows the minus sign. So 4, negative 11. All right, over here, we're going to write x squared plus 14x. We're just copying it down. Leave a space. subtract the 55. Now we take half the middle number. We're going to square it, which is 49. We do that to both sides, which gives me a negative 6. Now, again, in the previous part of the unit, when we were going to be square rooting both sides to find the intercepts, then we would have realized there are no intercepts here because we would have the square root of a negative number, which means we'd end up with I. But we're not doing that here. We're just moving this back over here by addition. And that gives me f of x equals x plus 7 squared plus 6. Which, remember, this is the same as x minus negative 7. So my vertex is going to be at negative 7, comma 6. Again, didn't have to do that, but just more practice. Sorry, the pen stopped working. All right, graph the following. Well, remember, this is x minus negative 6. So that means my intercept is at negative 6, negative 1. I'm not sorry, not my intercept, my vertex. Not speaking well today. So negative 6, negative 1. So right about there. All right. My axis symmetry is going to be at x equals negative 6, going right through the x value. Since this is a positive 2 out here, we know where it's going up, which gives us a minimum. All right. And then I'm going to type this in my calculator. If I can get my calculator to work. All right, clear. And then type in 2 parentheses x plus, nope, not minus, plus 6. I guess I could have written minus negative, but we'll leave it like this. Keep it simple. Squared minus 1. Graph it. Let's see if we end up over there. Yes, we do. Going to look here for some points. Obviously, we need to go to the negative side of the equation to get something that we can do. There we go. 7 will work. Okay. So negative 8, 7, and negative 4, 7. Right there. And right there. And then negative 5, it was negative 5, 1. And negative 7, 1. So there are my points. Now, on this problem, this won't be on the test. This does not make sense for the x-intercepts to say it because they're not whole numbers. They're in between two numbers, so we're not even going to worry about that right now. Domain does not change. Negative, positive, infinity. It is going up towards positive infinity, and it bottoms out at negative 1. And we put a bracket there. And remember, that negative 1 comes from right here. All right, x squared plus 10x plus 27. Let's put that in right now. X squared plus 10x plus 27. Okay. So, first off, let's look at the directions. It says convert into vertex form. So we have to do our completing the square. Not too terrible. Remember, leave our space equals negative 27. Very important to make that negative. We take half of the 10, which is positive 5, and we're going to square it, which is 25. We do that to both sides. That gives me negative 2. Move that back over by addition, and that gives me x plus 5 squared plus 2 equals y. And remember, this really means minus negative 5, so my vertex is at negative 5, comma 2, which we kind of saw that from looking at the calculator. My axis of symmetry we know is x equals negative 5. I don't know why I was going to put parentheses there. No need. All right. Again, it is a positive, happy parabola with a minimum. X-intercepts, well, there are, in this case, we can actually say, wow, I don't know what's happening with that. we can actually say none, all right? Because we can see, oh, love technology. We can actually see that there is none when we looked at the calculator. So domain, not changing. Range, again, it's -2, and it's an upward one, so it's going up towards infinity. See, we don't even need to graph this to be able to get this information. And now we're just going to go to the calculator. We're going to go get some points. Okay, and there's not a lot. So we're going to use -6.3, -4.3, -3.6, and -7.6. That's all that we can get off of the calculator. So we had -5.2 as the vertex. We have -4.3 and -6.3. And then we have 3.6 and 8.6. Sorry, 7.6. And there we have it. That's a horrible parabola, but you get the gist. Okay, convert into standard form. First, we're going to FOIL or double distribute this. Then we're going to send the 2 in to everything. Then worry about this last. So this stays. I don't know why I wrote the equal sign there. X times x. Remember, you square the first term. You multiply and double. So -3 doubled is -6. Square the last. So we're going to get a positive number every time we square. -7. Now I'm going to send the 2 in. Can't do that -7 yet. I have to do multiplication first. So 2x squared minus 12x plus 18 minus 7. Now we can combine those and get 2x squared minus 12x plus 11. All right, standard form. Okay, so remember, x equals the opposite of b over 2a. That's how we get the x coordinate. All right, so we're going to identify a, b, and c. We really only have to do a and b, really. -1, 8, -9. So opposite of b over 2 times a gives me -8 over -2, and that's +4. Okay, so we know 4 comma something. Now technically, we need to plug 4 in here and here and do the crunching of the numbers. But why do that when we have this nice handy dandy calculator? So y equals, clear it out, -x squared. That's the wrong one. Okay, let's try that again. -x squared. Okay, there we go. Plus 8x, sorry, plus 8x, and then -9. So it looks like 4, 5 or 6, but we don't have to guess. We have the table here. We just need to go, scroll down here to 4, and see what we have. 4 comma 7. Which is a minimum. Sorry, let's see. Check that out. No, it wasn't. It was a maximum, wasn't it? Because it's negative. Since this is negative, I don't need to look at the calculator. It's a maximum. And the domain, this time it's going down towards -infinity. And it tops out, again, remember the y tells us that, at 7. And we're going to use brackets because it actually hits 7. Number 13, real quick, A, B, C. 4, -16, and 31. Opposite of -16 over 2 times 4. That's 16 over 8, which means the x value is 2. Now I can plug 2 in, or I can just come here real quickly and put in 4x squared minus 16x. Let the calculator do the heavy lifting for you. Plus 31. Graph. Now, this is one where we don't see it. Notice what the y-intercept is, 31. So I'm just going to go to my table and go to 2 and see that the vertex is at 215. It's a happy parabola. If you think about it, here's the thing. It's starting up here and going like that. Okay, it's it's above our screen. It is definitely going up, and the range starts at 15 and goes up towards positive infinity. All right, start off, put every one of these in the calculator. So I have 2x squared minus 4x minus 1. See what we're dealing with here. Okay, looks like 1, -3 or something. Again, ABC, because it's not always on the calculator screen. You can't always see it in the table, so we should always do this, just at least get the x part. So opposite of B over 2A. That's 4 over 2. Sorry, 4 over 4. 2 times 2 is 4. I can multiply, which is 1. So it's 1 comma something. So we go back to our calculator, go to the table, and it's 1, -3. It is a happy parabola with a minimum. The axis of symmetry is going through my x coordinate. Okay. Again, on this one, we're not going to worry about the x-intercepts. So 1, -3 is right here. The domain, not changing. Negative infinity to positive infinity, going to keep going left and right. The range, again, remember the correlation here. It's going up towards positive infinity. We use a bracket here, parentheses here. Now let's just get some points and we're done. So 0, -1, and 2, -1. And then 3, 5, and -1, 5. And there is our parabola. We're good to go. Next one. Got a -1 here. So it is going to have a maximum and it's going down. All right. So we're going to put that in the calculator. First thing, go to y equals, hit clear. Negative x squared minus 14x minus 51. Hit graph. Okay. So over like, -7, -2, -8, -2. Go to the table. Let's confirm with this. So A, B, C, -1, -14, -51. Opposite of B over 2A. That gives me 14 over -2. And I was correct in my assumption. It looked about -7, and it is. -7 comma something. What is that something? -2. Lucky guess. Axis of symmetry goes right through that x coordinate. So -7, -2 is going to be right there. All right. X-intercepts. Well, this is going down from here, so there's actually none. We can write that because we know that. Domain is not changing. The range, don't even need a picture. We know it's going down towards negative infinity, which is always on our left side, and it tops out at -2. Bracket. Now let's just get some other points and finish this bad boy. All right, so -9, -6, and -5, -6. Mirror images. And then -8, -3, and -6, -3. And there we have our parabola, which will eventually hit the y-axis down at -51. All right, applications, word problems. Product, remember we're going to be multiplying. So two consecutive integers. So that's x and x plus 1, and we're multiplying them, equals 2756. So let's do the math. We distribute the x and move that 2756 over, making it negative. Now, remember, I taught you a little trick here. Just take the square root of 2756. It's going to be somewhere near that answer. Okay, 52 point something. So I would try, 53, 54, 52, 53, something like that. So I do 52 times 53, and look what I got, 2756. So my two numbers are going to be 52 and 53. I want one left over, so that's positive, that's negative. That gives me an answer of positive 52 and negative 53. But wait, that means 52 and 53 are obviously the answer, but you can also have negative 53, that's a horrible 5, I was thinking 3, and negative 52. Okay, so both will give you 2756, positive. All right, last page, real world problem. Fireworks launched from the ground that has a height of 0 with initial velocity of 80. That's our middle number. So velocity is 80, the V is a clue there, and our height upon launching was 0. So what's the equation? Negative 16, well, we do h of t, negative 16 t squared plus 80t, and technically we can stop there, okay? Because we don't have to write plus 0, but technically that is, what the height is, but we don't have to. It's up to you. You can just leave it right there. Now, what's the height of the firework after 1 second? Well, let's use our calculator. Let's get in there and put in our equation. Clear. Negative 16x squared plus 80x. Substituting for t. Here's our graph. Graph's not going to help us much. But we go to the table and see when will it be, where will it be at 1 second? 64 feet. Find the maximum height and how long it took to get there. Well, A, B, C. A is negative 16, B is 80, C is 0. So how long did it take to get there? That's the x coordinate, so we're going to do that one first. So x equals the opposite of B times 2a. That gives me negative 80 over negative 32. Well, let's see what that is. So come out here. 80 divided by 32, I'm just doing positive because negative divided by negative is also the same. Ooh, 2.5. So time is 2.5 seconds. Now, there's two things to do here, okay? You got to calculate where 2.5 would be. So you could just do negative 16, parentheses, 2.5, parentheses, squared, plus 80, parentheses, 2.5. You're basically just plugging in 2.5 into the equation, and you get 100. Another choice, haven't shown you this, is you can adjust your table, and you can have it change instead of by 1, by 0.5. And then when you go in to look, there's 2.5 seconds right there, 100 feet. So two different ways to do this, up to you what you're most comfortable with. All right, when will it hit the ground? Now technically you're supposed to factor here, which on this one is not bad, because if you take out a negative 16t, you get x minus 5. Or t, I'm sorry, t minus 5, whatever. Well, when you set these both equal to 0, this gives you 0, and this gives you 5. which obviously it launched from the ground, 1, 2, 3, 4, 5. Okay, and if you look at your calculator and you go down to 5, or you keep going until you see a 0 here on the right, it is 5 seconds. But as we talked about in class, it won't always be here. It might be in between two numbers. And we'll talk about that on the next one because that does happen. So I need to graph this. To make this fit, I'm going to count by tens. And I'm only going to write every 20 just for space. 40, 60, 80, 100. So we know at 2.5 seconds, 1, 2.5, it's going to be right there at 100. If we look at 1 second and 2 seconds, 64 and 96. So at 1 second, going to be just a little bit above there. And that's also going to be at 4 seconds, a mirror image. Then at 2 seconds, it's going to be at 96, kind of real close. And same thing there, mirror image. And then we just kind of try to hit the points. And there's our graph. All right, last one. Boy staying on top of a building that's 20 stories, that's 200 feet in the air. Well, that's the initial height. He throws a ball 96 feet per second. Okay, so that gives me h of t equals -16, that stays the same. Okay, plus 96t plus 200. All right. Where is it at 1 and 2 seconds? So I'm going to pull up my handy dandy calculator. I'm going to go to y equals. I'm going to put this in. So again, -16 x squared plus 96x plus 200. All right. So 200 is the y-intercept. That's where it's starting from at 0 seconds. So we're going to graph this, go to the table, sorry, and look at 1 and 2 seconds. Whoops, I'm in the negative zone. So there it is, 0, 200. In 1 second, it's 280. And 2 seconds, it's 328. So 1 second, 280 feet. And at 2 seconds, 328. Find the maximum height. Well, again, we need to identify A, B, C. Really just A and B, but good practice. 96 and 200. So, how long does it take to get there? Opposite of B, I'm not plus or minus, I'm thinking of the quadratic formula, over 2A. So that's -96 over 32. Sorry, this should be negative there. That should be negative. That makes this negative. And that goes in to 96 3 times. So 3 seconds. Where will it be at 3 seconds? Go back to the calculator. Let's look. 344 feet. When will it hit the ground? This is one of those ones that if you factored it, you'd have to use the quadratic formula. So let's just see where it hits, where it starts to get positive. Right there. And in fact, let's just imagine you probably weren't using this. And you just had this set to 1. It didn't register. Oh, I have it starting it there. Sorry about that. Second graph, because that's where I left it off at. So let's look at this. 6 seconds is 200 feet, then 88 feet, and then 8 seconds is in the earth, underground, 56 feet. So when does it hit the ground? Somewhere between 7 and 8 seconds. If you noticed previously, it was between 7.5 and 8. But this is fine, 7 to 8 seconds. Now we're going to graph it. So I'm going to count by 20s. And I'm going to skip every other line. So 20, 40, 60, 80, 90. I'm going by that. So that's going to be 120, 140, 160, 180, 200, 220, 240, 260, 280, and I'll just add 300 here. So it's starting off at 200 right here. Okay. In 1 second, it's actually at 280. We saw that right here. At 2 seconds, it's at 328. So kind of off a little bit, about right there. And then at 3 seconds, it's up here at 344. We're just kind of estimating there. It's back down at 280 at 4 seconds. And we said between 7 and 8, 1, 2, 3, 4, 5, 6, 7, 8. Somewhere closer to 8 is going to be hidden back down there. So there is our graph. Something like that. And that is it. Practice that calculator, you'll ace this.